Now we are going to be doing an awesome LeetCode problem that is called combination sum 2. This is the subsequent question to our original combination sum problem with some slight tweaks. Now we can see that this one is a LeetCode medium problem, but in my opinion, this can be categorized as hard problem sometimes as well, because combination sum in itself is slightly tricky to understand. And we can see that this one is a very popular LeetCode problem, also being asked at tons of companies. Basically, we are given a collection of numbers called candidates and we are given a target number. Now we need to find all the unique combinations in the given input array such that the sum of those values is equivalent to the target value. There can be more than one results, so we need to consider all of them. Now we are told that each number in candidates may only be used once in the combination, and we need to make sure that the given solution set must not contain any duplicate combinations. Okay, so now let's first try to understand this with an example. We are given this candidate array and we are given the target value to be 5. Now next thing is that we need to generate the unique sets. Now let's see that what are all the combinations that can generate this value 5. We can see that we have value 4 and we have value 1. So 4 and 1 is a combination that can sum up to value number 5. So that this can be one of the potential answers. Next one is we have value 2, 1 and 2. So once again we can generate value like this, and this can also be an answer. Next value is that we can do 3 to 2. This is also one of the subset that can generate the answer. But now there is one problem over here. We also have this 3 that we can utilize with this 2 to once again generate the target value 5. The thing is that value is also going to be 3 2, which we have already entered in our result. So we should not be reusing the same set in our results, because we need to make sure that this answer becomes unique. So if we, by considering these elements, we can only generate these three values or these three sets that combination to the total value 5. So we need to understand that this is how we need to solve the problem. So now let's try to see that what could be the potential solution over here. Now logically, the very first thing that it would make sense for us to do is that instead of treating all of these weird values side by side randomly, it would make much more sense to, number one, sort the given input array. Why am I suggesting to sorting the given input array? That has two reasons. Number one reason is that let's say that we have some values like let's say 10 and 15 and then so on and so forth, like 100 other values, okay? And we are given the target value to be 5. So the moment we reach to a value 10, then why do we even have to check possibility for all of these 100 values if we have already sorted the results? We know that all the values sum is always going to be greater than 5, which means it is going to be shortening the reach we will have to search for. That is a good benefit. Second benefit is that it will allow us to handle the duplicates in a more elegant manner. So what I'm suggesting is that let's say that in this case we have the values 1, 2, 2, 3 and 4. This is the input we are given. Now what we are doing is that logically it's very simple. We are just simply making decisions. And what is the decision we are making? We are iterating over the very first element. Okay, so let's say that we are currently passing through value number 1. We know that the target has to be 5, but our current sum that we have made so far is just value number 1. So we will need to add some more subsequent values. So let's say we decide to add value number 2 down this current path. So now the sum is 3, still less than 5. So once again we decide to add value number 2. So after adding this value, our sum becomes 5. So the moment our sum becomes 5, whatever the values we were currently having as part of our path, this is one of the potential answers. So let's mark this as part of the answer. Okay, that we currently have found one of the combination 1 to 2 as part of the answer. After doing this, there is still more possibility that we could have some other value that we might have missed on. So we will have to backtrack and once again see for other possible answers. So let's say that we do a backtrack at this position number 2, and once again this now the problem comes because this next element is already 2 and we just did a backtrack. But the thing is, we already considered this 2, so now we will have to consider value number 3. Okay, so let's say if we try to do this one, this current sum becomes 6. So the moment current sum becomes 6, we know that this is no longer a viable solution which means we will have to do a backtrack because this solution is leading to a value greater than 5, and once again we will have to repeat the operation for all the other remaining possibilities. So we remove value number 2. So once again, now with this value number 1, there might be some other solution with 1 and 3 that we could make. So we try to add value number 3. After this value number 3, the current value is 4. After 4, we add value number 4 over here. So doing this also brings our sum greater than 5, which means we will have to do a backtrack. We do a backtrack and we get rid of this value number 3. Now at this value number 1, we still have possibility to check for value number 4. There is still one more decision we haven't made. So let's say we do this one. The sum of this is actually 5, which means we found another set that corresponds to our correct result and our correct instinct. So we are going to mark this as part of the answer as well. Now once again, we know that we took care of all the things we could using this value number 1. So now we are simply going to go to the next element and not even consider 1, because we ran through all the possibilities we could with value number 1. So we don't have to worry about it. Now at this value number 2, let's say, let me just clean this up a bit. Now we are making a new decision tree, a new decision path where we have 2. Once again, we go to the next element, that is once again 2. After doing this, we go to the next element, that is 3. So now this sum in total becomes 7. So 7 is greater than 5. If 7 is greater than 5, going down this path 2 does not make sense. So we are going to ignore that. Ignoring this, we are going to be going with 3. So we are at this juncture and we found that current sum is 5, which means this is one more potential answer that we will have to record. So let's mark this one. Okay, marking this, we are not done yet because we may still find another results, we don't know. So we go to this next element 2 to 4, but this also leads to result number 6, which means we calculated all the possibility at this current 2 as being the very first element where we are calculating. Now the thing is, next element is also value number 2, and we can see that with previous element 2 we already calculated all the possibilities. So if we had a target value, let's say instead of over here instead of 5, if we had a target value 4, we would have a potential value 2 that is being generated by this 2 already. So we don't have to do anything over here. And also if we try to go down this path, let's say that we ignore my advice for now, and we say that currently we took care of this one, we took care of this 2, this 2 is still valid and legitimate. So now we have this value number 2. Once again we go down to the path, so we find value number 3 as the next potential match, and this matches. So should I add it to the answer? No. Why should I add it? Because I already calculated this one. So what I'm suggesting is that once we have this sorted list, we simply check that for any particular element that we are trying to iterate over in the recursive manner using our backtrack function and recursive function, we first check that whether if it is the same element as the previous element. If that is the case, we already calculated all the possibilities and added to our answer, so we can simply ignore that. So now we are all going to be ignoring this 3 as well. Now we are left with this element number 3. So let's try to make possibilities with this 3, and we are just going in one direction. We are not going in the opposite direction because we calculated all the possibilities. So with this 3, the only possibility we have is to add value number 4. The sum is going to be 7, so greater than 4, which means this leads to no result. So we already calculated all the possibility as 3 as well. Next is the only element 4. Once again, if we calculate the possibility, there is only going to be just element number 4, which is not 5, so we cannot put it in the answer. After this, we are done with all the elements in our input, and this is the answer we need to return. So now let's do a quick recap. What we did, we calculated that what was the backtracking function, and we also calculated that what is going to be a recursive approach. For a recursive approach, we need two items. We need a base case and we need a recursive call or recursive function. We know that what is going to be our backtracking logic, that at every possibility, the moment we either reach to the target value is equal to 5 or target being greater than 5, in either case, if it is 5, we are going to be adding it to the answer. If it is greater than 5, then we are going to be going to the very previous element that we were iterating over and remove that from our current list and follow along with the remaining possibilities. That is option number 1. For our recursive, the logic is quite straightforward. Base case is going to be that the total sum of the current elements that we are iterating over, it's either 5 or greater than 5. If it is equal to 5, we add it to the answer. If it is greater than 5, then we can simply just move forward or jump to the next element. And for the recursive function, we are simply going to go in a normal fashion by adding the current value and removing the current value from the given input array, and just making a recursive call by adding a new value that is next inside our given array. So if we see the coding solution, it would make much more sense, and this is, in my opinion, a very beautiful solution. So I hope you understood what I was trying to explain. Now let's quickly see the coding solution for this one. So here is the coding solution. First of all, we are generating our result where we are going to be storing the list of array list. Then we are sorting the given candidates array. Plus we are going to have our backtrack recursive method where we are going to be doing backtracking and also making recursive calls. And so now let's understand our backtrack method. So first we are passing in the result list that we just created. We are also maintaining a current list. We are also maintaining the candidates array that we are iterating over. On top of it, we have provided our target and we have provided our start values. Okay. Very first thing we are doing is checking that if the given target is equal to 0, then we are going to be adding the current list inside our result, and we are simply going to do a return from our current recursive call. If that is not the case, we will run our for loop where we are simply going to iterate over all the values that are currently present inside the candidate. Very first thing we are doing is skipping the duplicates. So we are checking that if the current candidate is same as the previous candidate, we can simply ignore that value. Next, we are also doing an early termination if the sum becomes negative, because at every given moment, the moment we see a new ith value, we subtract that ith value from the given current target element. And the moment we realize that this is going into the negative, we are simply doing a break operation. Now, if that is not the case, we add the current value to our current array list that we are maintaining. Then we once again make a recursive call with the current value, which contains one more value right now. And we provide the target minus candidate I, because we are subtracting the value from the target that we need to achieve. And we update it with the next element inside our for loop. And that's it. Now, once we get a result back from our backtrack, we simply remove the very last element, and we once again do the same operation for other possibilities that we are yet to calculate. So this approach should work. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions, which is pretty good. So once again, I would be posting this solution in our GitHub repository, so you can go and check it out from there. Thank you.